Have you ever wondered how those amazing images of our planet, from detailed weather patterns to tracking global changes, make their way from distant satellites all the way down to your screens? It is truly fascinating to think about the journey this critical information takes. The simple answer is that Earth observation satellites often relying on a sophisticated network of other satellites to relay their data back to ground stations. Instead of sending information directly to Earth, which can be limited, they use intermediary relay satellites acting as high-altitude data couriers. The core mechanism behind this involves the orbital characteristics of different types of satellites. Many Earth observation satellites operate in low Earth orbit, or LEO, which means they orbit relatively close to our planet, typically between 160 and 1,200 miles up. While this allows for high-resolution imaging and rapid coverage of Earth, it also means these satellites are only in direct line of sight with a ground station for short periods. To overcome this limitation, they transmit their data to relay satellites positioned in geostationary Earth orbit, or GEO, about 22,236 miles above the equator. These geosatellites appear stationary from Earth, providing a constant link to ground stations. This system effectively extends the communication window for LEO satellites from a few minutes per orbit to nearly continuous coverage. The observation satellite captures its data, then beams it up to a nearby geostationary relay satellite. That relay satellite, always in view of a ground station, then forwards the data down to Earth. This two-step process ensures that valuable information, whether it is about crop health, sea ice melt, or atmospheric conditions, is not lost during orbits when the LEO satellite is out of range of a ground station. A prime example of this ingenious system is NASA's Tracking and Data Relay Satellite System, known as TDRS. This network of geosatellites acts as a space-based switchboard, constantly collecting data from various Earth-observing spacecraft, including the International Space Station, and then relaying it to a central ground terminal. This enables near real-time data transmission, significantly speeding up the delivery of critical information. These relay systems handle immense volumes of data, often using high-frequency radio bands like K-band and Ku-band to ensure fast and efficient transfer. Ultimately, this clever use of relay satellites ensures a seamless flow of vital information from space, providing us with constant, up-to-date insights into our dynamic planet. It is how we can track hurricanes with greater accuracy, monitor climate change impacts more precisely, and respond to environmental events with increased speed, all contributing to a better understanding and protection of our world.
Join us at Space Tech Insider, where innovation meets the infinite. Discover the future today.